Picture this, a pipe bursts, hidden deep inside your walls. What exactly happens in those first 60 minutes? You might not even see it right away, but a massive, incredibly destructive chain reaction is already underway inside your home. Just to put the sheer volume of this threat into perspective, an aging water heater can suddenly rupture and dump up to 50 gallons of water in an absolute instant. We aren't talking about a little kitchen spill you can just wipe up with a paper towel. We are talking about a catastrophic volume of water, aggressively migrating through your living space, soaking into floors, climbing up walls, and pooling into your structural foundation.
So let's dive right into this. Welcome to today's Explainer, where we are demystifying the disaster life cycle, specifically looking at the science of water damage restoration. Because, as we're going to see today, saving a property from sudden water intrusion goes way, way beyond just grabbing a mop and a wet vacuum. It's actually a strict, methodical, and incredibly fascinating building science.
Here's our roadmap for the Explainer today. Number 1, causes of water damage. Number 2, the race against time. Number 3, 3 categories of water. Number 4, the science of drying. And finally, number 5, prevention and protection.
Section 1, causes of water damage. We'll be looking at the unique vulnerabilities of Fuquay-Varina. Fuquay-Varina is actually the perfect case study for us because the age of a building completely alters its risk profile. In historic homes, like the ones you find in the older tobacco district, you've got these vulnerable pier and beam crawl spaces, right? Plus galvanized plumbing pipes that literally corrode from the inside out over the decades. But then, on the flip side, newer construction south of Highway 55 faces entirely different enemies. Those recently built homes use engineered lumber and OSB sheathing that absorb water incredibly fast. Plus, they often suffer from improperly sealed window flashings that just invite water right in during heavy wind-driven rain.
And add to that the hyperlocal environmental triggers. We're talking about native, clay-heavy soils that really don't drain well at all, which ends up funneling storm runoff right into foundations. Then you have intense summer thunderstorms that cause sudden flash floods in low-lying areas, especially around neighborhoods near Bass Lake. Fast forward to winter, and those wild freeze-thaw temperature swings cause stressed pipes to burst. Pair all of that with aging infrastructure, like those 10-year-old water heaters we mentioned, and you've got a constant, year-round recipe for disaster.
Section 2, the race against time, the critical response window.
Professionals treat this whole process as a high-stakes race, and here's exactly why. Within the very first 60 minutes, water spreads exponentially, completely saturating drywall and flooring. If emergency extraction doesn't start right then and there, the damage just multiplies. Between 24 to 48 hours, especially in a humid climate, dormant mold spores actively begin to colonize. To stop this progression entirely, a full structural drawing process has to be meticulously executed, and that generally takes about 3 to 7 solid days.
So the absolutely crucial thing to grasp here is the dangerous difference between visible surface water and invisible trapped moisture. What you can actually see pooling on the floor, well, that's really only half the battle. The real threat is the water secretly trapped deep inside your wall cavities, hiding under the flooring and soaking inside ceiling assemblies. If you only dry the surface, you leave this hidden moisture behind, and it will silently destroy the structure from the inside out.
Section 3, 3 categories of water. Classifying the threat level.
Not all water is created equal. Professionals actually break contamination down into 3 distinct levels. Category 1 is clean water. Think a broken drinking water supply line or clean rainwater. The immediate health risk there is pretty low. Then you step up to Category 2, which is gray water. This might come from an overflowing dishwasher or a washing machine, and it carries a medium risk. But Category 3? No way. That is black water. This comes from sewage backups or outdoor storm flooding. It's a severe biohazard posing massive health risks, and it requires highly specialized personal protective equipment and EPA-registered antimicrobial treatments to handle safely.
Section 4, the science of drying, beyond mops and shop vacs.
The core of this entire industry relies on a concept called psychrometrics. It's a big word, I know, but it's basically the precise science of moisture dynamics. You see, restoration professionals don't just set up a few fans and hope for the best. They actively manipulate temperature, humidity, and air movement to create vapor pressure gradients. This scientific process forcefully pulls stubborn moisture out of dense building materials and into the air. And that is absolutely vital during those humid North Carolina summer months when the outside air is already thick with moisture. To make sure this is done perfectly every single time, the industry relies on a gold standard called the ICRC S500. Having this certification means technicians aren't just guessing, they are following strict, proven building science protocols for equipment placement and documentation.
In fact, insurance carriers heavily rely on this exact standard to prove that a property has been properly and safely restored to code.
The protocol itself follows 3 exact phases. Phase 1 is emergency mitigation, which means rapidly extracting thousands of gallons of standing water and removing unsalvageable materials right away to stop the spread. Phase 2 is structural drying. This involves using closed drying systems with commercial-grade, low-grain refrigerant dehumidifiers. And finally, Phase 3 is final verification, confirming the structure is entirely 100% dry before any rebuilding takes place.
But how do they actually know the moisture is gone? They use highly specialized technology. Thermal imaging cameras pick up evaporative cooling signatures, showing clear temperature drops where hidden water is still lurking behind finished drywall. Then, they combine that data with penetrating moisture meters that read the precise moisture content locked deep inside the wood framing. It really leaves nothing to chance.
Section 5. Prevention and Protection. Safeguarding your home.
Okay, here are your actionable takeaways to safeguard your property starting today. First, replace your washing machine hoses every 5 years and swap out those water heater tanks every 10 years, well before they reach their breaking point. Make sure to clean your gutters twice a year to keep water flowing away from your foundation. Insulate your pipes in vulnerable crawl spaces and attics to prevent those brutal winter freezes. And finally, install smart water detection devices near your major appliances so you are immediately alerted the very second a leak begins.
Now, if the worst does happen and you face a water emergency, remember this golden rule. Document absolutely everything. Take photos and videos before the cleanup process even begins. Comprehensive visual evidence, combined with those professional daily moisture logs we talked about, is the absolute key to smoothly navigating your homeowner's insurance claims and proving that the mitigation work was completely necessary.
Which leaves us with one final, very important thought. Look around the building you're sitting in right now. Based on the invisible risks, the aging pipes, and the structural vulnerabilities we've explored today, is your home silently ticking toward a water emergency? Take the time to check your critical systems today, way before that 60-minute countdown ever begins. Thanks so much for joining us for this explainer.